Hello and welcome to Game Assets with Houdini and Unreal Engine 5, Volume 2. This is part 2 of a multi-part tutorial series that will also work as a standalone course for people who haven't completed Volume 1. This course is designed to teach you how to create procedurally generated maps using the wave function collapse algorithm in Unreal Engine. During this course, you will learn the core concepts of wave function collapse and how to implement the algorithm in Unreal Engine using blueprints, as well as how to customize it to suit your specific needs. We will also cover various techniques for creating interesting and diverse maps, including tweaking tile probability weights and creating constraints to guide the generation process. I am your instructor, Matthew Jukes, a technical artist working primarily with Houdini and Unreal Engine at Weta Effects. We will step through each stage of implementing the algorithm, from setting up our tiling modules, the core logic loop, and optimizing and distributing the calculations across multiple frames. Key takeaways: implementing wave function collapse in Unreal Engine using blueprints, setting up tiling 3D modules, blueprint optimization and data handling, distributing complex calculations over multiple frames, creating flexible and reusable procedural workflows and tools. By the end of this course, you'll have a solid understanding of the wave function collapse algorithm and how to use it to generate unique and diverse game environments. Whether you are a game developer looking to add some variety to your maps, or a hobbyist looking to explore the possibilities of procedural content generation, this course has something to offer you. So let's get started. Okay, welcome to Chapter 1. We're going to start by implementing a wave function collapse algorithm. It's a really good algorithm for placing modules together, which works really well for the way we've been sort of building things in Houdini. And this is going to be implemented purely in Blueprint, running straight inside Unreal Engine. And you can see it running here, the background. These are all just some placeholder assets that we're using, and we'll be adding more to this as we progress. So a little bit about what wave function collapse is for those that might not be familiar. Essentially, it is, in this example, it's a 3D grid. It also works in 2D. You might more commonly see it in 2D, but basically it's made up of a bunch of like nodes on the grid, and every node can be any possible module to start with. And then you collapse one down to a single module, and then that updates the modules around it on what they could possibly be. And eventually the whole thing collapses, hence the wave function collapse, and it builds these little procedural worlds. Has some certain advantages over other kinds of procedural generation, whereas you've got quite a lot of art directability over the modules, and we can build in rules like weights and certain other things, limitations on where models can be placed to have some more control over it. So I'll do I'm going to bring up this quick example here. So this is by Oscar Stelsberg, who is, this is quite a well-known example. He's developer of Bad North and Townscaper, which uses both use wave function collapse in their level generation. And this is just a really nice example to show how it works. So full credit to him. Check out his stuff, it's really good. You can see here, these are all the possible modules, and this one's set up. You can see these little numbers here, or you might hopefully be able to see them on the recording, of what can connect to what. So it basically uses 3 colors, pixel colors, on the edges of each module, and if they match, they can go together. Here, and see, this is our unsolved wave function. Everything can be everything right now. But if we click, say, this one here, these collapse around it because only certain ones can appear around it. Click the next one, and it collapses further and further until we just keep clicking. It will completely collapse because there's no more possibilities left. And essentially what we're going to do is implement this in 3D. A similar system. We're going to be using a socket-based system rather than these triple sort of socket-based systems, but essentially the same thing in 3D. And nice thing about wave function collapse, it'll work on kind of any grid. So this could be implemented on a triangle or a hex grid, and squares, like, well, a 3D grid like we're using. So to get started, we're just going to start a blank project. And let's call this, we call it whatever you want. I'm going to call it wave function. Actually, chapter 1, volume 2 is what I'm going to call it. Keep it blueprint. All this, we don't need data content or ray tracing. You could do third person if you want, but we can always add this in later as well. And while that's generating, I'm going to have a quick look at these pre-built modules that I've made. I'm not going to go through the creation of these because they're dead simple. Doesn't feel like a good use of time to go through all that. So they're just really simple. Ground, slope, vertical, slope top, corners, all that sort of thing. And then these ones which are the sort of edges of the map. And then they're just color coded. So green for grass, red for like sand or coast, and blue for cliffs. And that's just going to be make it easier to slap on a texture so they look like something. But this is all placeholder at this stage. It's just to implement our algorithm. Okay. And these are also, I'll include the scene as well as I'll include the actual geo. So if we close that now. Okay. So let's just make a new level, and we just want a basic level. Delete that. And let's save this in maps folder. Save that map. And we're going to make a new, and we're going to call this one modules. And then under that, let's add a meshes one. And just import all these. Don't want collision for these. Turn on nanite, even though they don't really need it, but according to Epic, it is good just to turn on nanite for basically everything that supports it. So we'll do that. Shouldn't need to do anything else in these. We might need to change the scale. I can't remember if I included that, but don't want to create new materials. Cool. Just import all of these. Cool. Okay, so we don't need to change the scale. They're all scaled correctly. Save those. And I'm going to create another folder. I want this one under there. Materials. And one new folder. It's going to be textures. Okay, for the textures, I've got all these ones that I downloaded from Megascans. What I'll do is since I can't redistribute these with the tutorial, I'll include the links for the particular Megascans assets. Remember, you can, it's in here somewhere, tools, I think it's under add. Can't remember where it is in, there is a way to add, open it in, there we go. Open Quixel Bridge. And I'll include what assets they are, so you should be able to search them and add them in here. I'm just going to drag all these in, and I'm just using albedo, AO, normal, and roughness. So let them all import. Just so we have some textures to work with. And again, I'll include links to all of those assets. And if you don't know, you can just sign up for Megascans with your Unreal account, and they're all free as long as you're using them for Unreal Engine, which we are. And finally, I'll include these materials as well, just to be downloaded, or with the content, the tutorial content. So what I'm going to do, these are all just US assets, so I'll just copy them, and we're going to find our project, content, maps, sorry, not maps, modules, and materials, and just copy them in there. No, they should be in here. Okay, so Water 1 is basically nothing, it's just a constant colored material. And this one is for our placeholder modules that we just imported. It's pretty simple. It's just absolute wheel position, which we sort of used in our previous one to do the sand. So this is just using the horizontal absolute wheel position to drive some textures. So we just need to hook these back up. So the ones I am using for this, this SGM, which is the grass. And remember which one is, there's a sand one in here somewhere. This one here, I believe. Let's just check which that one is. Yep, I believe this is the sandy one. You can always change these later, but... And then there is a cliffs one in here, which is this VL1. Okay. So I'm just going to select this one in the content browser so I can come to this. Assign that quickly, and that means I'll be able to quickly find the roughness. We've got roughness, normal, and then ambient occlusion. Oops, and I've already broken that. So I'm just going to go through and hook these up. I'm just going to pause it while I hook them up because I'm confident in your ability to go through and do these. Okay, so I hooked those all up. Just albedos or base color, roughness, normal, and then our ambient occlusion. I mean, I know ambient occlusion isn't strictly physically accurate, but we're not really going for physically accurate with what we're doing. We're doing slight stylization. So, and these are placeholder again. So now we just need to come to our meshes and open all these. Or if it will let us. No. Yeah, open all these. Just wait for them to open. It's going to. Let me mass open these. No. No, maybe. There we go. And just assign the material instance of it. And let's make sure our material instance, I'm going to have to rehook this up to our parent because it didn't transfer over, but that's okay. And just go through and hook these all up. And one thing that hasn't come through, I don't think I turned on, just noticed, import vertex color options. We need this to be replace. That's better. So I'm going to pause and assign these and re-import them as with the vertex colors on. Okay, so they're all assigned with the base material. You can see, I mean, they're not amazing looking, but again, they're placeholder, but they'll do. So the next step will be to start actually creating our implementation of the wave function collapse. Okay, so the first thing we need to do is start defining our modules. So I'm going to make a new folder. It's going to be our blueprints. And in here, a new blueprint class that is type actor. I'm going to call this BP underscore WFC for wave function collapse module master. Cool. Let's open this up. Okay, so we're going to need a couple of things in here. So under here, let's start defining what we're going to need. So first thing I'm going to put in is a rotation index. And this is going to be an integer. So all of our modules can be facing one of 4 directions. This is what this will determine. And then we're going to do a bot padding. So this is just in a 3D grid, how much padding it is from either side, like on the bottom range on the negative axis. So this should be a vector. Okay, and then we need to duplicate that. This will be our top padding. So padding for our positive axis. Duplicate this again. And this is going to be our bot max depth. So max depth is going to determine how far into the grid. So if we want things just to stick around the edges, this is what we'll use. And it'll be mainly used for like our coast. So top max depth. And then finally, one more variable, and this is going to be our weight. So the sort of weighting we give to this module appearing. Okay. And leave all that as it is. And then we need to add some components under here. First one we need to add is a static mesh. So all of them are going to have a static mesh, at least one. Later on, we'll be adding multiple static meshes to certain modules, but each one has to have at least one. And let's give it our SM flat to start with. Okay. And now I'm going to need some more variables in here as well. Okay, and this first one we're going to add, so we're going to actually start adding our sockets. So we're going to be using a socket system. So this is going to be positive x socket. And we're going to have to make a type for this. So come back here, and in our blueprints, we want to just search enum or enumerator. And this is going to be E WFC socket name. Okay, and let's add a bunch to that to start with, and add in some of our sockets. So basically there's going to be 6 sockets on each module, each side, positive and negative X and Y. Yeah, and then positive and negative Z for above and below. So the naming, the sort of way we're going to set up these socket names is we're going to start with the sort of direction. So it's horizontal. And then description, so this is going to be flat. 50 is sort of for where the module sort of sits. So this is like 50%. So if you imagine a 1 by 1 or a cube around this is halfway up the cube. And then we're going to append it with the sort of rotation index, but for this one, since it's symmetrical, it's going to be S, because it can connect with any other of this, no matter the rotation. And the next one we're going to need is flat to vertical, which is our sort of slope, and that's 50, and then underscore 0. And we're going to need 4 of these because we need 0, 1, 2, and 3. And the 0, 1, 2, 3 defines our rotation index of this socket. And then we're going to need almost the same thing. Gee, we need to define one of these as top, and this one should be flat to vert bot. So that's our slope going up, this one. So this edge here would be our slope bottom, and if we find this one, this would be our slope top. Let's go through and do these. If you want to do your own naming convention, that is totally fine, as long as it's consistent. So a lot of this early setup is going to be just defining a whole bunch of things until it actually starts to work. There's a lot of sort of groundwork to sort of put in before this is going to really do anything. But I'll explain along the way what each piece is doing, and hopefully it all makes sense. And then we need our first vertical one, which will be our vert flat 50, and then same rotation thing. So this is for our, like this one, like connectors along here. Yeah, here, sorry, above and below. These would be technically a horizontal. So like connecting that to that. And trust me, this will get more exciting. We just got to put in this sort of groundwork setup. And to start with, I'm just going to add 6 more of these. We need another horizontal one, which will be our flat vert. So that's for our vertical walls to join together. And then finally, we need to account for empty space. So like this, the front of this can't connect to anything other than empty space. And the way we're going to handle that is we're going to have 2 sockets for this sort of thing. It's going to be called omni, because it's going to be in any direction, vertical or horizontal. And I'm going to call it invalid to empty. And it's going to be symmetrical. And then we're going to have a second one called omni, and that's just going to be called empty. And that's also symmetrical. And the reason we've got 2 here, so this one, invalid to empty, is only going to be able to connect to empty, but not itself. And empty will be able to connect to empty or this one. That's so when we have something like this, we don't have 2 of them that directly face each other. It's going to leave a bit of a gap in between. But we'll set that up a bit later. We just need the naming right now. Okay. So with that set up, we'll set up the rest of these sockets in the next video. Okay, so let's finish setting up the rest of these sockets. So obviously we need to set this to our socket name enum. And then need to just make that, turn that on, instance editable. No, we don't really need to do that, but it helped us distinguish it. And I'm also going to put it in a category for sockets, just to keep things tidy. And let's put these ones into just a data one. Or settings. Actually, what we should do is to go, keep this nice and tidy. Let's go WFC / to put it into a sub category. And the rest of these we will put into just WFC, wave function collapse. Just so on our children, we created this, it'll all be nice and tidy. It takes a little bit of extra time to do all this sort of housekeeping stuff, but it's definitely worth it. Okay, now we just need to make 6 of these for each axis. So pos y socket neg y socket positive z socket, and then our negative z socket. Okay. And now what we want to do to make this a bit easier for us to sort of visualize what sockets are which, I'm going to add a text render to this. And we'll call this positive X text. You might have guessed we're going to add 6 of these. First, let's drag off this one into positive X. And let's set this to center, and text bottom is fine with that. Let's do something that's easy to read, probably a pink. Won't clash with anything else we've got. Something very visible and easy to read. And maybe let's drop the word size down to like 18, just because these are going to be a bit longer. And yeah, let's leave it like that. And then we just need to make the other ones for the other axis. And we're going to leave them all rotated the same way, so you just have to read it from a certain direction, but that's fine. It's just a little helper for us. As we set up. And what we'll be doing after we set these up is making them automatically reflect our settings in here. Cool. Now we just need to go to our construction script. And we're going to set up a couple of things. One thing we also need is in sockets, add a new variable. And this is going to be called our socket map. So this is just going to be a way for us to get the enum based on a string easily. So make this a map and make that socket name. Cool. So just holding Control, click and drag that into there in our construction script. Make sure this is clear before we do anything with it. And then we need to do for each. Do for each is one word. And then find our wave function collapse socket name enum. I'm going to loop over all of these. And then we need to go enum to string. Control drag in socket map again. And go add. Drag that in there. And then drag that into there. A little bit of housekeeping. Q is a great shortcut to remember. It automatically aligns connections. Now we need to do a new function. I'm going to call this update display text. jump back over to our construction script. And when that loop is complete, we want to update our display text. Now back over here and display text. What we need to do is just sort of get all of these components. Let's make sure they're ordered. So X, Y, Z. Now you can Shift D to align them. And let's just put them all like that, nice and neat. And then we need to do set text. And then we also need all of our sockets here. So just holding Control, drag all of these in. And then we need enum to string. And we can just drag that into there. So making sure we're aligning the correct ones. Select all those and hold Q to make them nice and neat. Now we just basically need to copy this for all of these. So add a bunch of these in. And then chain them all together. And you can also copy these. Do some aligning. You can also select them all. Right click, find alignment, and go distribute vertically. No, it doesn't do a good job with all of those. All right, I'll do it manually. Again, it's just good practice to make all your node graphs nice and tidy. Or if you're working in like industry and someone else has to look at it, you don't want them to have to like decipher a bunch of spaghetti. And when you come back to it as well. And if you're like me, it's just a certain satisfaction in making a nice neat node graph. All right, just double check that we've got all this in the correct order. So XX, YY, ZZ, XX, YY, ZZ. Cool. So save that. I also like to have my save on compile always on normally. So now these should all be updated. Okay. So this is our base module setup. We'll be adding more stuff to this, but that's all we need for now. Okay, let's start setting up some of our basic modules. So I'm just going to close all this, leave that one open. And let's make another folder for our modules. And click this one, create a child blueprint class, and move it into there. Okay, so this first one is, we'll call this one flat. Actually, let's be a little bit more explicit in our naming, or add a wave function collapse module flat. Okay. So this one need to set up. So these are all correct. What we need to do, I don't like how the text renders not two-sided like that by default. It's a little bit annoying. But that's right. And there's not any anyway. So this top and bottom one, if we open up our sockets, these need to be invalid to empty, both of them. Okay, the way the text was displaying was annoying me with the base material. So I quickly made a material folder, made this mtext, which is just a masked unlit material with two-sided turned on, plugged in the color I wanted, and then you just have to grab this, put down this font param, and then a lerp negative 90 to 90, and I mean, I just grabbed this section directly from the this. So if you browse to it and open, you'll see it in there, but you just need to put that stuff down. If this is annoying you, like it was me, then we can just update all these with our own one. That makes them much easier to read. Okay. So back to what we were doing. So we've got our flat one. Duplicate that. And we'll make the next one. This will be flat to vert bot. Close and save that material. And then we need to swap out this static mesh to flat to vert bot. And so I'm going to need to move that up by default, like a little bit. So 200. Same for this one. Negative 200. And this one, let's go text top. Oh, that should be better. And those ones, since they're in there, our horizontal alignment should be not left, right. And then this one should be left. Okay. So that one is correct, but none of the other ones are correct, and that one are correct, but nothing else is. So our positive Z should be vert flat 50. And our two sides here, which are our y-axes, should be horizontal flat to vert bot. 0 for both of those. And then this back one here, which is our negative x, needs to be invalid. And we're only making, so this module here is perfectly symmetrical. So no matter which way it's rotated, it's always going to be the same. This one will have 4 different alignments, but we're only going to create one because we'll set up a thing to rotate it for us and update these socket names to be 0, 1, 2, 3. Same for that one. Okay. Duplicate that. And let's do our flat to vert top. Okay. Make that top. And then update our sockets. So positive X is now invalid to empty. And that one is flat. And these just need to be top 0 instead. And the one above is now invalid to empty. And the one below is vert flat 50, 0. Okay, hopefully you can see how these will start connecting. Like that will match that there. These would match in a line. That would match with this flat. Or with this piece here. Okay, duplicate this. And let's make this one our vert flat. And we're not setting any of this stuff yet. We'll go through and do that later. What we should do on our module master is make our weight default 1. Hopefully that's propagated to all of these. Yep. Find our flat. Right. So these are both our x's invalid to empty now. Positive y's should both be pos flat vert 0. And our top and bottom, that one's correct. This top one should also be vert flat 0. And let's make our flat to vert top corner. So I'm not going to set up all of these, we're just going to set up the bare minimum to start with, and we'll add more and more as we get our wave function collapse working. Okay. So this one, we need our top corner. Okay, so positive x is correct, negative x is not. That should be flat to vert top 1. So that's rotated, so this 0, 1, 2, 3. Rotating this way. And then flat to vert top, that one is correct. So 0, yeah. So if it's facing out along Z, it's 0. It's facing out along Y, it's 1, etc. And then this one down here, we need to also change. And I also need to change this positive Y. Positive Y socket should be invalid to empty. So these three should be invalid to empty, and then this one down the bottom here finally should be vert. And we've got a socket that we haven't made yet. So let's come back and open up our socket names. We don't have anything for our vertical corners. So this is going to be vert outside corner. Actually, let's just say corner, and we'll assume a corner as our outside or convex corner. And then we'll do inside corner for when we add concave corners. Corner 50, 0. And make our rotations for this. Now this bottom one, vert corner 50. Okay. Okay, nearly done. We need 3 more basic modules. That should give us all we need to start with. So let's duplicate this bottom one, bot corner. Okay. So that is correct there. Oops, don't move that. That one's correct. That positive Y here should be horizontal flat. And then this one here up the top should be our corner 50, 0. And this one here, which is our negative Y, should be, I think that's actually correct. It's just this one here that we need to change. So that one, which is negative X, should be flat to vert bot 1. Save that. And then we need vert corner. So this is our outside corner. And we need to update. That's correct. This one is not correct. So that's positive Y. That needs to be invalid to empty. Now, that one's correct. This one here should be vert flat 1. And then these two should both be vert corner 0. And the final module we need, duplicate any of these, is going to be our empty module. So the static mesh should be cleared, nothing in there. And all of these should just be set to empty. And that should be all we need, all the modules we need to get started. So we've got an empty one, our flat plane, the start of the slope, top of the slope, the actual face of the cliff or slope, top corner, bottom corner, and then our vertical corner. Okay, so the next step will be to make these rotate themselves so we can instance, because we're going to need to instance 4 versions of these and have the sockets correct and that sort of thing. Okay, so now we're going to set up a function to rotate these modules and update these sockets accordingly. So if we jump into our module master and come to the event graph, we can delete these and put down a custom event. I'm going to call this rotate module. And then we want to grab our static mesh. And we're going to add location rotation. Sorry, not that one. No, yes, that is the one we want. You just want to split the struct pin. Grab our rotation index. And we need to multiply this by 90. Let's just align these. Get that one slightly lower. Okay. Now off of this rotation index, we want to do modulo or %sign. Oops, trying to do Houdini shortcuts in Unreal. Now you also want to do an add. And just copy this twice. And this first one is going to be 3, and then 2, 1. And this modulo is going to be 4. And make 3 copies of that. Do some alignment. Okay. Now what we need to do, we need to add a variable in here. And this is going to be called start sockets. And we'll add that socket name. This just needs to be an array. And what we're going to do, if we come back over to our construction script here, get that. Actually, no, need to set that. Chuck it in here. Make an array. And we need to get our horizontal sockets. Add some pins to that. Okay, now back over in our event graph. Get our start sockets. And then we need to get a reference. Hook these up to each of these, hook it up to our start sockets. Align these. So Shift WASD is your alignment to align to like snap all of them along a particular direction. Okay, and now we need to make a function in here. And this is going to be called rotate socket. And we're going to need 2 inputs for this and 1 output. First input is our in socket. Second input is our rotation index, which is an integer. And our output is an out socket. Okay, so what we need to do, enum to string, and we want to pass into an array our delimiter, which is what's going to determine how this gets split into an array, is underscore. Unless you've done a different naming convention, then this might be different. And then we need to do a get. So we need 3 of these. We need 0, 1, and 2. Should be all of our separate elements. Like we should have horizontal, say that this was it, for example, we should have horizontal flat 50 S. Now I'm going to put down a switch on string. Add 1 pin and do capital S. So this is for our symmetrical ones. So on S, what we're going to do is just return the socket we put in. Since it's symmetrical, it does not need to be rotated. So we can just return that. Now we need to do a little bit more if it's not a symmetrical one. So what we need to do take this, do an add, do you want that one in the top there? Didn't automatically convert. So find string to integer. And then modulo or percent, and do modulo 4. Drag off this top one, do an append. So we're just basically rebuilding a string with the rotation index to move it along, and modulo will make a wrap around. So add a couple of pins to this, drag that one into C, and that one into E, because we need to add our underscores back in. And now we can use the socket map that we built earlier. Do a find. And that is what we'll return. Let's drag this down a bit, make it a bit tidier. Okay, so that's our rotate socket. So if we come back to our event graph now we need to drop down our rotate socket. And what we should do is come over here, back to it quickly, make it a pure function. So that way it'll be just like this. We won't need to run an executable through it. Make some more of those. And do one for each of these. And then we need to plug this rotation index into it. Let's keep trying to do the Houdini shortcut for adding a dot. And just hook up all of these. And then we just need to set. So you just hold Alt. And we need to do this for all of our horizontal sockets. So positive X. And this next one is positive Y. This needs to be in a particular order. Because if we look at, which I'll finish hooking these up first and explain what's happening a little bit more. and then negative X. So if we look at like this one here, or maybe a slightly simpler one like this one here, we got positive X, positive Y, negative X, negative Y, so we're rotating around this way. And what's happening is if we need to rotate this socket to match when this rotates, we need to look at what this socket is, because this will now be facing here. Check if it's symmetrical, which it is, so it won't update, so this socket now becomes that one. And say we do this one needs to look back at this one. And then it sees this isn't symmetrical, so it needs to rotate it, so it adds the correct number to the end, which would be 1 in this case, I believe. Okay, so that should do all that. Now we just need to do it for the vertical sockets, which just need to rotate if it's not symmetrical, just the socket itself. It doesn't need to change what the socket actually is. So, 2 more of these. So all we need to do for these ones, hook up our rotation index. Let's add a dot there. Make it tidier. And then we just need to get our positive X and positive Z and negative Z. And then we can just set them. And then we just need to do update text display. So what we can do to test this, we rotate module, make this call an editor, and then make that visible on an instance. Remember why I had that on edit on instance before. Same for these, for testing these. After this, these don't really need to be editable on instances, but well, actually these ones might be. Okay. So if we grab a module like this one, we can set the rotation index to like 2 and rotate the module. And they should work, but see, that one has not, so flat to vert bot is incorrect. So we've got some, a couple of things we need to debug. And I have a pretty good idea of what it might be. So if we come to our master module and come to our construction script, it's most likely these. There might be something else causing an issue, but these are definitely wrong. I forgot to put these in order. So these need to be the same rotation order. Or in the reverse rotation order actually, because they're looking, when they get looked up in our rotate socket. Sorry, not in our rotate socket, in our rotate module, it should be getting looked up backwards, like in reverse direction till we're rotating. Let's try that again. And yeah, these are working now. Numbers are updating. And this all appears to be correct. So this will allow us to have our code rotate our modules so we don't have to create 4 different versions of each of these non-symmetrical ones. Okay, so just to recap everything that this is doing, we just set up for this rotate module. So this rotate module will be called by our actual wave function collapse. We won't be calling this ourselves. So our rotation index comes in and that represents the 4 rotations of each tile. So 0, 1, 2, 3. And we're just multiplying that by 90 to set the actual rotation of our module. And then what we do down here is we need to get what the sockets are, like the corresponding sockets for each one. So say our rotation comes in, and then we add corresponding values for the 4 sides. And then we're doing modulo, so it wraps around. So you imagine on a module, we have side 0, 1, 2, 3. When we add 3 to 3, it keeps wrapping around with the modulo rather than counting up to 6. Because modulo just gives us the remainder when you divide by. And then we look up that in our start sockets, and we rotate that by the amount. So this rotate socket, coming in looking, first it checks if it's a symmetrical socket, which means it doesn't need to be rotated. Otherwise, we just, rebuild the string, taking out our key values or key little identifiers, and just sort of increment them around. Find that socket in our socket map, and that's the new socket. And then we set that socket to the corresponding socket slot, basically. So this is the socket value, and this is our actual socket sort of slot. So we do that for our 4 sides. And then we do slightly differently for our top and bottom sockets, because these won't be they don't move around. They just, the socket stays the same. We just rotate the socket itself. Whereas these ones, the socket needs to change sides. And that's sort of how this is working. And this just saves us setting up 4 sockets, basically, or 4 different modules for things that aren't symmetrical. This will just do it automatically for us. Okay, we can start implementing our wave function collapse blueprint now. So we need to create a new blueprint. We can do an actor, bp underscore wave function collapse. And let's come to our event graph. So this is going to run on begin play. And let's start by dropping down a custom event called generate map. And off begin play, we'll generate the map. Now we're going to start by making a new function. And this will be create base module instances. And what we're going to do in here, then make that one of the first things we do. So one of the first things we need to do is instantiate an instance of all of our modules in all of their various rotation states as well. So we'll have one of these, we'll have 4 of the rest of these, and 1 empty. So what we do is we're going to need that information stored somewhere, so we need a variable. And let's call this module templates. And this is going to be an array. And we need to find our master module. Or module master. We want a class reference. So let's get that. We'll need a loop over all of these. But we also need to add our modules in. Let's compile that and then add a bunch of these in. See how many we've got in here. 8 items. So we've got our empty, we've got our flat, and our various slope / cliff pieces. And just go through and add them all in. Cool. Now we need to spawn an actor. And that's our class because we're looping over them. And we just need to get our actor transform of the actual wave function collapse actor. And one thing we want to do, we come back over to our module master and come to our rotation index. We want to expose on spawn that parameter. That means we can pump in our rotation index or set it as we spawn. Next, we want to store all these modules. So let's duplicate that and call this base modules. And find our master module and do an object reference instead. So get that. And we want to add. So these will all be stored for later. And we're also going to get the scene component. Actually, we can just go, should we either just drag off here and go set visibility on the static mesh. Actually, no, we do want it on everything. So actually, we can just do set actor hidden in game and make that hidden. So we don't want to see these, they just need to exist in the world. Okay, now we need to check if we need to make the other rotations for this. We only want to do this if they're not symmetrical modules. So what we need to do is come back over to our module master and we're going to add a null function. I'm going to call it check symmetrical. So to check if it's something symmetrical, one of these is symmetrical, we need to get all of these. And our two Z. So we just check if these are equal. So if they're all equal, all of our horizontal ones, and then if these ones, we do enum to string and do an ends with an S. So if all these are true, and I add and add 3 more pins to this. And we just need to return Boolean be symmetrical. So little b for booleans at the start is Unreal convention. Make this pure. And jump back over here. Now we can check if it's symmetrical. Hold B, click to put down a branch, which will let us check. So if it's not, if it is symmetrical, we don't need to do anything else. If it's not though, we're going to do a for loop. And a for each loop. And we're going to loop 1 to 3 for our rotation indexes. And then we just need to copy that. Connect our class. And just add some dots to reroute this cleanly. Okay, and our rotation index is this index of our loop. And then we just need to do similar stuff that we're doing up here. So we can copy these. Add it to our base modules. Set it hidden in game. And the other thing we want to do on this one, clear out the space. We need to call rotate module. Okay, so that should be our should spawn all of these. So let's do a quick test. Check that in there. We will also end up making categories for all of this stuff. It reminds me, let's just start doing that now. So for this one, let's go WFC vertical slash modules. And this one should be instance editable. And just drag that one in there as well. I'm glad they fixed a bug that was in 5.0. That means if you didn't have spaces in here and you dragged something into it, it would add a space and give you different categories. So that's nice that they fixed that. We should have all of our modules, and you can edit this in the instance. And if we hit play, you should see we've got all of these modules. We can just attach here or hit F8. They're there, but they're invisible. And they're in the same location as this. So I didn't zero it out. And we have each of these. You can see their sockets are updating as well, which is good. So this all appears to be correct so far. And it's good to make sure, come through and check that this is all working, because this is going to get quite complicated. And if you've gone through and you haven't checked anything as we're working, one little thing can break the whole lot. So it's good to make sure each stage is working.